Good evening, algebros and algegals. Unless you are watching this in the morning, in that case, go to school. Welcome back to Mathematics. Today we are doing another HSC revision video. This one is focusing on the entire topic of differential equations in the Extension 1 HSC course. We're going to go through a variety of questions to cover as much of the topic as I can and hopefully get you a bit more prepared for HSC style questions on this stuff when it comes around to it. Okay, we're going to go through a variety of difficulty, starting off with this one from 2020 HSC. It's an E2 level, so it's not meant to be super challenging. For 2 marks, the derivative of y with respect to x is equal to 2y. We want to find x as a function of y. Okay, let's dive into it. As with all my revision video lessons, if you want to get the best value out of these, if you've already encountered this content before, you should pause the video when the question comes up on screen, have a crack yourself, and then watch through my solution and see if we arrive at the same conclusion. Okay, so first of all, I see we have a differential equation and the entire right-hand side is in terms of y. So we can't integrate both sides yet. What we'll need to do first is we'll need to take the reciprocal of both sides and turn them both upside down. So left-hand side is going to become dx on dy. The right-hand side will become 1 over 2y. Okay, now we can move the dy across to the right-hand side and then integrate both sides. So we need to know how to integrate 1 over e to the 2y. And the way we're going to do that is we're going to use a negative power and write this as e to the power of minus 2y. So it looks like this. There's just a 1 on the left-hand side now with the dx, and now we can chuck a couple of integrals in and get some reverse calculus going. Okay, left-hand side, the 1 is going to integrate to an x, and that's going to have a constant as well. I usually like to put my constants with my x's just because it feels right to me, I guess. On the right-hand side, the integral of e to the minus 2y, this is going to stay as e to the minus 2y, but we are going to divide by the derivative of the power, which is minus 2. So we have e to the minus 2y divided by minus 2. Now there's not much left to do here. It just says to write x as a function of y, so we just need to make x the subject. So we'll just put that constant over to the right-hand side. And because it's a constant, when you move it across, it doesn't really change positive or negative because we don't know what the number is because there's no information in the question. We can write this in a little bit of a better way if we want. We can just bring the e to the minus 2y down to the bottom, but that's kind of optional. That right there in green is our final answer, getting us 2 marks. But if you flipped and tried to integrate, you would probably be getting 1 out of 2 for this one. Okay, hopefully you got the same as me and we're off to a good start. Let's move on to an E3 level question now. A lot of flapping animations. I'm sure that won't get annoying. Okay, this one is a differential equation involving x and y. We have d1 dx equals minus x over y. Passing through 1, 0, and we want to find the curve that satisfies the equation for 3 marks. So when you have a differential equation involving x and y, you want to put the y's with the dy, and you want to put the x with the dx's. So we're going to multiply this y across the left and multiply the dx across the right. So it looks like this. Now all the letters are with their family, and now we can integrate both sides like this. Just going to put the negative out the front. Okay, integral of y is y squared on 2, and integral of x is x squared on 2. Don't forget your constant. Okay, now we can figure out what the constant is right away, or if you want, you can go ahead and times everything by 2. It doesn't really matter when you find the constant, but usually finding it earlier rather than later is going to be the smart bet. Let's go ahead and find it now. So the question says that when x is equal to 1, y is equal to 0. So let's chuck that in. We'll put a 0 on the left and we'll put a 1 here to look like this. Now if we solve this, we get 0 equals negative 1 squared. So that's going to be negative 1. And so we have 0 equals minus 1 plus c. So the constant must be 1 if we solve for that. Okay, put that back into the equation. We don't want to rearrange to make y the subject because it doesn't ask us to find y as a function of x. It just says find the curve. And this is a curve. If we put the negative x squared over to the left-hand side, it looks more like this. And so the curve that passes through this point is actually the circle, x squared plus y squared equals 1. Looking at the markers feedback from 2020, a lot of people lost a mark here because they didn't put the x squared over to the left. They did like a square root of both sides and then picked a positive or negative and it was wrong. So you don't need to go any further. Just put on the one hand side that's a curve. We've answered the question. Okay, onto a applications question, another E3 level. This one's from 2022, and it's talking about coffee into a cup. So we have room is 12 degrees, coffee into a cup. The coffee starts at 92 degrees, and it's too hot, apparently. How about you just drink a cup of cement, just drink it anyway. Temperature T, rate of change given by this formula here. K is blah, blah, blah. T1 is a constant. Okay. Takes 5 minutes for the coffee to cool to a temperature of 76 using blah, blah, blah. So show that this is the equation. All right, this is our first part of the question for 3 marks. It's the bulk of the algebra involved. Okay, so first thing we need to know is we're going to get all the information that's useful from the question, and then we're going to use it to build our differential equation. So looking at dt on dt equals kt minus t1, what you need to know for a cooling question like this is that the constant inside the bracket here, that you've got T minus this constant, that constant is what the temperature is approaching. Okay, so if you've got coffee in a 12-degree room, the coffee is going to approach 12 degrees as time goes to infinity. Okay, so we need to know, to answer this question, that T1 is equal to 12. All right, some more information we can extrapolate. It says that initially the coffee is 92 degrees, so temperature at time equals 0 is 92. And it says after 5 minutes, we've cooled to 76, so T5 is 76. Okay, here's our information. Here is our equation. Let's see if we can go ahead and solve this. So notice that I've just rewritten the equation, but I've changed the T1 to a 12. Okay, now our goal is to solve this equation and make it look like this. And let's dive right into it. So on the right hand side, everything is in terms of capital T, which is the top letter. So first thing we should do is take the reciprocal of both sides and turn them both upside down. Now we can put the dt across with the t's and leave the little dt on the left with the 1. So 1 dt on the left, on the right we have the fraction times dt. Putting in an integral, and because k is a constant, I'm just going to put 1 over k out the front to simplify things. Okay, now we can get our calculus going. Left-hand side integrates to t with a constant, and the right-hand side we can integrate using a natural logarithm because the top of the fraction is the derivative of the bottom. So we've got t plus c on the left, 1 over k out the front of natural log of t minus 12. Don't forget your absolute values when you're integrating with a logarithm. Okay, now we can probably figure out what the value of... No, we're just going to rearrange this first. We are going to... we've multiplied everything by k here. So the right-hand side, when we times by k, gets rid of the fraction. T times k is kt. And when you times the constant by a constant, it's still a constant. So we can just leave it as c, just to make things a little bit more simple. Now we can get rid of the natural logs by taking the exponential of both sides. So if you raise the left-hand side to the power of e, the logarithm vanishes. So the right-hand side is raised to the power of e as well. Now we're going to get rid of our absolute values because we can split this apart by writing this as e to the kt times e to the c. Okay, so we're just using like a reverse power rule here. E to the kt times e to the c. E to the c is just a number, so we're just writing it as a. So a is the placeholder for e to the c. And because e to the something is always going to be positive, we don't really need to worry about the absolute values anymore. We don't need the plus minus because the thing at the front is going to have to be positive. Okay, add the 12 across and we are starting to get towards our equation. This is what it looked like. It had a 12 at the front, it's got a thing at the front, and then we've got to figure out what k is. All right, so here's our equation. Let's use our initial conditions to figure out what a and k are, and then hopefully it'll look like what they told us to make it look like at the start. So initial condition, when little t is equal to 0, capital T is equal to 92, take 12 off both sides, and then you're going to get that a is equal to 80, because e to the power of 0 is of course 1. So we have 92 minus 12 is equal to capital A, and so a is 80, which is what we were trying to achieve. Now we'll use the second bit of information from the question to figure out an expression for k. So there's our equation we've figured out now. Letting the left-hand side equal to 76, and we're going to make the power equal to 5k. All right, now the goal is to rearrange this to make k the subject. So we need to be really good at rearranging logarithmic and exponential equations to have some success in this topic. So take away 12 off both sides, and 76 minus 12 is 64. Now we'll divide both sides by 80 to get e to the 5k equal to this. Now we're trying to get the k out of the power, so we'll do natural log of both sides. When I do natural log of the left-hand side, it's going to cancel out this e and give me 5k. And so also 64 over 80 is, of course, 4/5. Who knew? All right, natural log of both sides. Left-hand side turns into 5k. Right-hand side turns into natural log of 4/5. Now we just divide by 5, which means we're doing a fifth of both sides. So we get k equals 1/5 log 4/5, which means we get our equation, which the question told us to try and aim for 3 marks in green. So there we go. There's the steps. So you needed to know what the value of t1 was in the equation. Needed to know to flip, to integrate, use logarithms. A lot of content knowledge here, culminating in 3 marks for us. All right, now we have our equation. The optimal drinking temperature is 57 degrees. Says who, Nessa? You bunch of nerds. Find the value of t for when the coffee reaches this temperature, giving your answer to the nearest minute. So we're going to set temperature equal to 57, and we're going to solve for t and see what we get. So left-hand side equals 57. We're going to take 12 off both sides to get 45, and then we'll divide that 45 by 80 to get that out of in front of the e to the bloody blah. So minus 12 divided by 80 gets us this. Now we'll once again get rid of this power of e by doing natural log of both sides. So the right-hand side, 45 over 80, works out to be 9 out of 16, and I've done the natural log of the right-hand side. Natural log of the left-hand side, we'll just bring this power down. So we have t over 5 times log of 4/5. I've decided to write that as 0.8 for some strange reason. Now we just need to solve for t. So we're going to divide by log 0.8, and we're going to multiply the 5 across. So we can probably do that in one step because we're really smart. So log 9/16 divided by log 0.8 and then times by 5. Chucking that into the trusty old Casio calculator gets us a value approximately equal to 13 minutes to the nearest minute. So there you go. Solving logarithmic equations and exponential equations. Super duper important for advanced extension 1 and extension 2. So if you're rusty at it, it's definitely a skill I would recommend working on. All right, I'm really starting to get annoyed by that bird thing now. Okay, E3 level from 2021 HSC. This was only worth 1 mark. They gave you a direction field in your writing booklet, and they said, hey, for 1 mark, can you please sketch the particular solution that passes through P? Which seems like not too stressful because you're just going to sort of go with the flow in the diagram and just draw a curve. But actually, in 2021 HSC, less than 20% of the students got the mark for this. So remember, in the HSC, there's no half marks. So if you're like kind of right, it's pretty much going to be a 0. So the trick that I think most people fell for here is that the tangent at P is kind of pointing down a little bit. And I feel like a lot of people might have put their curve down here and then down here and then down here, which is actually wrong. Because if we follow the tangent line a bit carefully, it's more going in this direction, which brings us up sort of in this direction following these tangent lines up here. Okay, so the notes from Nessa were that make sure your students know that you're never going to cross any of these lines because these are all tangents. So this should be just touching your curve. The curve should never be passing through them. Here's the sample solution provided by Nessa because I don't know how to draw it on my screen because I'm stupid. But as we can see, it's going with the flow. It's touching tangents, but it's never crossing them. Okay, so you want to try and stay in the lines, touch the tangents, but do not touch them. And this is the example that would have got you 1. If you went down south and then went out here, you would have unfortunately got 0 out of 1. Okay, we are now onto the big boppers towards the end of the video, some E4 level questions. Here is probably the hardest exponential equation that's been in recent HSC at the time of recording this video. We have x minus 2 dy dx equals xy. We're trying to find the solution that passes through 0, 1, and it's worth a whopping 4 marks, which is something like 5% of the exam. Okay, so it's a differential equation involving x's and y's. So we should try and get all the x's with the dx, and we should try and get all the y's with the dy's. So the dx is going to go across with this x. The x minus 2 is going to get divided across to the right-hand side, and this y is going to get divided across to the left-hand side. So when we fully rearrange everything, here's all the y's on the left, the dy here, the 1 over y over here. The x is still there, the dx has gone across to join his friends, and the x minus 2 has divided across to be underneath the fraction. Okay, now we need to solve this by integrating both sides. And here's where I think this question is actually really unfair, because an integral like this, x over x minus 2 dx, this is taught explicitly in extension 2 using a method called separating variables. This isn't really mentioned in the extension 1 syllabus. So this is a question where extension 2 students had a huge advantage over extension 1 students, which is why I'm guessing it was an E4 level question that a lot of people got wrong. So in conclusion, Nessa, you're a bunch of dogs and you don't know how to write an exam. Do better. Anyway, so here's how we do it. We write the top, the x. We're meant to write that as x minus 2 plus 2, because minus 2 and plus 2 is just nothing. So I haven't really changed the value of the top. But now I can split this into two separate fractions, where one of them is going to be x minus 2 over x minus 2, and the other one will be plus 2 over x minus 2. The reason we've done that is because x minus 2 over x minus 2 is just 1. And so 1 plus 2 over x minus 2 is the more integration-friendly version of x over x minus 2. Extension 2 students would have known that straight off the bat. Extension 1 would have really struggled. So again, a bit of a dog of a question. So anyway, chucking that in on the right, writing this as two fractions. Left-hand side integrates using a natural log, and then the right-hand side is going to integrate. We're going to have 1 turning into an x, and we're going to have this turning into 2 times the natural log of x minus 2, because the derivative of the bottom would be 1. Okay, now our goal is to figure out what the constant is and then to find our particular solution. So we're going to try and make y the subject, which is going to be a headache, but we love headaches. That's why we chose extension maths. Okay, so figuring out our constant, subbing in the fact that when x is 0, y is equal to 1. On the left, you get log of 1, which is just nothing. We get nothing plus 2 times log of 0 minus 2. And this right here is why it's really important that you use absolute values when you integrate with logs, because here the absolute value is going to turn this minus 2 into a plus 2. So we get 0 here, nothing here, we get 2 times log of 2, and then we have constant. All right, so solving for c, by moving the 2 log 2 across, we get c is equal to minus 2 log 2. Okay, we're almost there. Now we just need to make y the subject, and we are done and dusted. How are we doing for time? Pretty bad. All right, so chucking into our answer right here, minus 2 log 2. Now the issue here is that we've got logarithm here, and logarithm here. This equation is going to be much easier to handle if we turn everything into a logarithm, which is one of the sneaky parts that make this a really high level question. So what we're going to do is we're going to bring this 2 in front of this logarithm up into the power like this. And now because it's being squared, it's always going to be positive, so we don't really need the absolute values, which is kind of a common trend in these questions. The 2 in front of the log 2, we're going to bring up as well. And so we have log to the power of 2 squared, which is log 4. Now, x, the really clever way of writing x in terms of logarithm is we can write x as log of e to the x. Because natural log and e to the power of are inverse operations and they cancel out. So log e to the x is actually equivalent to x. And it's just a really clever way of having your entire equation all revolve around logarithms. Because if everything on the right hand side is a logarithm, we can then use log algebra to simplify. What I mean by that is when you have log plus log, you can combine these together and multiply the subjects. And when you have log minus log, you can combine by dividing. So the right hand side, when we smush it all together, we have e to the x times x minus 2 squared by combining these. And then because we're minusing log 4, the 4 is going to divide underneath. Okay. If you're not pretty good at log algebra, that made absolutely no sense, and I'm really sorry, but I don't know how to explain it otherwise. All right, we need some more room, and then to finish off, we've got log on the left and log on the right. We're just going to get rid of the logs and say y is equal to this. I know there's an absolute value here, but everything inside this logarithm here is positive, because e to the x is positive, something squared is positive, and 4 is positive. So we don't really need the plus minus, because this is always going to be plus. So we can just ignore it and just hope that the marker knows that we know what we're talking about. Anyway, that there in green is worth 4 marks. And well done if you got it, because very few people in 2022 did, which is why it was such a high level question. And yeah, this sneaky bit of integration, I guess, is now worth knowing for Extension 1 students, because who knows when they're going to throw another curveball like this at us. Okay, I think we're going to do one more. Yeah, we're going to do one more. One more bird. Go away. Certain country, population of deer estimated to be 150,000 in 1980. Logistic equation growth given by this thingy right here. T is number of years since 1980. C is the carrying capacity. Now, carrying capacity is the maximum amount that a population can grow to. In the year 2000, the population was estimated to be 600,000. Using this fact, which is going to be a useful bit of algebra, show that the carrying capacity is around 1,130,000. Oh my god, I'm sick of my own voice. I'm sure you are too. All right, let's extrapolate, which is a really fancy word. Let's get all the useful information out of this question. First of all, this is going to be really useful because otherwise they wouldn't have told us. We've got the equation given to us, which we're going to have to play with and do a lot of hectic algebra. This is a really tough question, by the way, and it's 4 marks, so it's absolutely brutal. We have the initial population in 1980 is 150,000, so we'll make a note of that. And then in 2000, which is 20 years later, the population was 600,000. Okay, we're going to try and show that C is approximately equal to 1.13 million. Let's quit yapping and start integrating. Here's our info, here's our equation, and let's try and get into it. So first of all, common theme for today's question. On the right-hand side, the only variable is capital P, which is the top of the fraction. So that tells me first thing we're going to do is take the reciprocal of both sides and flip them upside down. Okay, now we do some integration. Before we do some integration, we're going to put the dp across the right-hand side to join his friends, which is the capital P's. dt is remaining on the left with its one and only. All right, we can tie this up a lot on the right-hand side because 1 divided by 0.1 is actually equal to 10 because you're just going to times top and bottom by 10. And c over c minus p and a p on the bottom as well. The question said, hey, here's a really cool way of splitting that up. You can write that as 1 over p plus 1 over c minus p because this is a lot easier to integrate than this. So they've given you the sort of step up to say, split this into 2 fractions and then party on from there. Okay, Nessa, let's do it. Let's integrate both sides. Integrals on both hand sides. I've just put the 10 out the front because that's where constants go. I've also been very clever because I'm quite good at maths and I've said, hey, the bottom of this fraction, the derivative of this is -1. So I would really like the top of the fraction to be -1. So I'll put a negative there and a negative there. Everything cancels out and everything's cool. Let's go ahead and do some integration. Left-hand side is going to turn into t with a constant. The right-hand side, we're going to have natural log of p minus the natural log of c minus p with a 10 out the front. So the whole thing. Okay, cool. So now we are trying to use this equation. We're trying to use the information to figure out what C is and use the further information to figure out what capital C is. So we've got 2 C's to find, a little one and a big one. Let's make some space. Okay, we're going to start off by simplifying the right-hand side a bit. Once again, using log properties. Log minus log, we can combine as 1 and do a division. So P minus C minus P. Now we're going to use our first initial condition, which is that when t is equal to 0, p is equal to 150,000. So I've chucked 150,000 here, chucked a 0 on the left, and now this very quickly gets us that the value of the constant is 10 log of this nonsense. So, and because this is all positive, because c is the carrying capacity, 150,000 is going to be less than the carrying capacity. So this fraction is positive. We don't really need to stress too much about the absolute values from here on. Okay, put it back into the equation and it looks like this. And it just looks like it's getting worse before it gets better. But here is our equation and we are now going to use this. Thankfully, the question didn't ask us to make P the subject because that would be an absolute freaking headache. We are just going to sub in the fact that when T is equal to 20, P is equal to 600,000. And hopefully this information will help us show that C is equal to this. That's our quest. It's tough. Let's dive into it. Okay, left-hand side. Come on, computer. Okay, before we do that, we can use a little trick to make the right-hand side a little bit easier to deal with in terms of algebra. It's useful to know that when you have a negative out the front of a log, you can use your reverse power rule and just put it up into the power and write this as log of fraction to the -1. A fraction to the power of -1 just does the reciprocal, so this turns into log of b over a. So this is going to be useful because for the second part here, where we have the minus out the front of this, we're just going to put the minus up into the power, which is going to flip that fraction upside down. And now we have log plus log, which is a little bit easy to deal with. So again, negative here went up into the power, which flipped the fraction upside down. And now log plus log is less stressful. Let's reduce some further stress by getting rid of these 10s. Let's divide everything by 10. So we get 2 here, and we get log, and we get log. While we're at it, let's use the fact that log plus log we can combine together by multiplying our two subjects. So this fraction times this fraction. Okay, we're steadily getting there. We're going to simplify this because the 600,000 on top with the 150,000 on the bottom, well, 60 over 15 is equal to 4. So this is just equal to 4. So we have 4 times the top divided by c minus 600,000 on the bottom. Now this is equal to 2, and now we're going to actually get rid of the logarithm because we're trying to solve for c now. So we're trying to get c out of this logarithm. So we'll raise both sides to the power of e. On the left, raising 2 to the e looks like this. On the right, when you raise it to the power of e, it gets rid of the ln because they're opposites, and then we just have the fraction thingy mess inside. Okay, now it's just algebra. We need more space. This question is an absolute mammoth. We're going to multiply the c minus 600,000 across to the left-hand side to look like this. Remember, the goal here is to make c the subject, and we're trying our hardest. We're going to expand out the left-hand side to get e squared c and 600,000 e squared. So far, that's all good. Now we're going to group all the c's together on the left and everything else on the right. So we're going to have e squared c is still here. Bring the 4c across the left. We're going to keep the negative 600,000 there, and we're going to add the 600,000 e squared across to the right. Almost there. Factor the c out of the left-hand side. Factor the 600,000 out of the right-hand side. Then we can just divide this e squared minus 4 across to the right. And now, thank God, we have something we can put into a calculator. And at this point, I was just hoping and praying, tapping buttons, press equals, and then hallelujah. It is 1.13 million. QED. Oh my God, I feel mentally and physically drained. Hopefully you feel less crap than me. Anyway, that is the end of the video. Pretty sure. Is there another one? No, that's the end of the video. Oh God, thank you. All right, cheers so much for watching. Cheers so much is not an expression. I hope that made you at least somewhat a little bit better at differential equations. And if there are any more topics in extension 1 or extension 2 that you could do with some help and could use a revision video on, let me know, because hopefully next term I'll have some more time to do these pretty regularly. So yeah, anyway, bye for now. Not forever. If you have any questions, hit me up on Instagram, send me a DM, and I'll get back to you with as much help as I can provide in whatever time frame I deem appropriate. All right, goodbye.